Welcome to my series on oil burner theory controls. This course is intended for advanced journeymen. I won't show you how to change nozzles and filters, that's not what I'm doing. This video is intended for advanced users. We will discuss controls, fuel pumps, service practices, troubleshooting, zone controls. Today I want to talk and start on fuel pumps. This particular pump here is a Suntech A2VA 7116. It's probably the most common single stage fuel pump that you'll run into. The newer generation is the clean cut with the solenoid on top. We'll get into that one a little later. But this one here I want to go over because it's very, very common. There is a strainer inside. This is the strainer cover that you're looking at here. There's 4 bolts, one on each corner, of course, and the strainer should be replaced at least once a year, or taken out and serviced, cleaned, new gasket installed. Okay, so I opened up to the spec page. I want to thank Suntech Fuel Pumps. This is their manual for this particular pump, and I got this right off the line. This is their PDF file for their pump, A2VA 7116 pump. Now, first thing I want to do is the pump identification. If we scroll down here and we look, we've got the pump identification, and there's the A2VA. So the first letter A, that signifies it's a single stage pump. If it was a 2-stage pump, there would be the letter B there. So A is single, B is 2-stage. Motor RPM 3450, very important because there's 1725 RPM burner motors. Old ones, you don't see them anymore, but you want to make sure you get the proper speed, or the valve will not open inside, and the older pumps, and you won't get any fuel coming out of them. Is one scenario. You just can't run at the wrong speed. That's kind of obvious. All right, then the strainer capacity, that's signified by the V. So strainer capacity V equals 3 gallons per hour. So on this particular pump, the strainer capacity is 3 GPH, 3 gallons per hour. So the maximum nozzle that you can run in that at 100 psi is 3 gallons. That would be your maximum. And I really don't really recommend maxing out a fuel pump. The last A there, if you see, shaft rotation and nozzle location seen from shaft end. So A would mean a clockwise rotation, right hand nozzle. Whenever you're looking, this is kind of elementary, but just in case you don't know that out here, whenever you're looking at motors, electrical motors, or you're looking at fuel pumps, and you're trying to determine the shaft rotation, you always look at the shaft end first. So if you hold the motor up in your hand or the fuel pump, look at the shaft. If the shaft turns right, then it's a clockwise rotation, and obviously if it turns left, it would be a counterclockwise rotation. So motors and pumps always go by the shaft end. Now let me zoom out here a little bit so we can see this diagram. Okay. And what this is the internal workings of the fuel pump. And I'll zoom this in. Again, this is a diagram, a PDF drawing from Suntech their website. So they drew this drawing. I did not. If I can get it all in here. Okay, I know this is really kind of hard to see, but let me go over the scale a little bit with you. Over here in the key section, the green is the suction. The gear set pressure, so pressurized oil will be the red. The blue is the return going back to the tank, and the yellow is the nozzle pressure. Alright, this is the internal working of this particular Suntech fuel pump, the single stage. Inside you have a gear set and an inlet port. The green's inlet, the blue is the return port. You have a gear set that pulls in, creates a low pressure, pulls in fuel, builds that pressure up to 100 psi, 140 psi, which is common now. You have cone valves inside. You have some diaphragms up at the top here. You have the nozzle port here. This is where your nozzle connection would be. Then you have, over here, you have your bleed valve, which is right here. Whoop, my computer just went tight. There we go. We have a bleed valve over here, which is your purge valve, which is also tied in to the return port from up here. And you have a way to set the pump pressure with a spring. So when the fuel oil overcomes the pressure of the spring, it allows it to flow out through the nozzle, which is... There's a fuel cutoff valve, which is inside the fuel pump. And its design and purpose is when the few split seconds, however long it is, for the pump to get up to speed and for the pump to wind down. When the motor starts, it doesn't start instantaneously. In our mind, in our life time frame, it does. But if we slow that down, we can see that it takes time. The motor takes time to get up to speed, and vice versa when it's shutting down. Well, at those 2 points, if we did not have some way to shut off the oil flow, then we'd have lower pressures, bad atomization, if any, more like big droplets of water squirting like a squirt gun into the fuel. You would not mix with enough air. It would be a very rich condition. You'd get a lot of sooting. So therefore, to prevent that, they have in the older pumps what they call a fuel cutoff. And it's basically just a valve that the pump has to come up to pressure, or in some of the older pumps up to speed actually, and before this valve would open and allow the fuel oil to be sprayed into the combustion chamber out through the nozzle. If this cutoff is bad, then you get what I mentioned before. You get this winding down, this squirt gun action, which will create a lot of soot, a lot of smoke, plug it up. So there's a test you can do with your fuel gauges and I'll show you how to do that later when we put the gauges on, and to determine if the cutoff is good or bad. Just real quickly, some of the technical data that I was telling you about is, for instance, here's the pipe sizing, the nozzle sizing, which we really won't get into that. I mean, good 1/4 inch threads, 1/8 inch threads, pipe threads. The strainer, as I was telling you, is a 3-gallon strainer. You can see that right here. The shaft is 5/16. This is just the instruction manual that comes with it. If we look over on this side, I'll put my camera over so you can see this side, and then we scroll down, or up, I should say. Okay, the nozzle pressure in this range for this particular pump is between 100 and 200 psi. You can see right up at the top, I'm coming down. The delivery pressure is 100 psi, so this pump is set from the factory at 100 psi. Okay, this is your flow rate. You got 3 gallons per hour at 100 psi at 3450 RPM with the number 2 fuel oil. If you increase your pump pressure to 200, your gallons per hour, if you see, drops down to 2. You have your oil temperature there, minimum max 50 to 115 degrees Celsius, Fahrenheit, I'm sorry. Now inlet pressure, 10 psi max. Return pressure, 10 psi max. The reason for that is and per code too, you're not supposed to install any type of valves of any kind on the return lines. You see it all the time. There's check valves. Sometimes if you don't, you get a free flow. When you take your cover off, oil just pours in. And that's not a good thing either. But the problem is that if the check valve, the return line should plug up on a 2-pipe system, or you leave a valve off, say a Firematic, you work on it, you forgot to open it after you serviced it, the inlet pressure on the here is only 10 psi, and you have a shaft seal in there, and at that pressure or slightly above it, the oil will leak out of that shaft seal into the burner housing, and then the fan will pick it up and blow it everywhere, or it'll leak all onto the floor. In some cases, if you have the oil tank is, say, outside above ground and the burner is actually below the oil tank, it's good to put an oil safety valve or OSV valve installed and inline, and that's right at the burner. And the reason for that is that if you the weight of the oil itself cannot flow down through into the pipe. So if you have a busted line or leaky valve or leaky shaft seal, the oil wouldn't gravity feed down. It takes a slight suction from the fuel pump to open this valve to allow the oil to flow. It's an OSV valve, so anywhere the tank puts pressure on the burner from the fuel oil, you should always have an oil safety valve. Now, single pipe, suction height, here we go. Very important. Single pipe, 6 inches of vacuum. Two pipe system, 12 inches of vacuum to prevent air separation from oil. And that's called cavitation. And basically cavitation is, there's small microscopic droplets of air that are in the fuel oil, in liquids, from just the air pressure alone here on the surface of the earth. So when we start taking those liquids and putting them under a vacuum, that air expands tremendously and it wants to come out. So if we're pulled too hard, say roughly 15 inches of vacuum, you're going to take and start cavitating. You're going to be pulling that oil under a vacuum. That air molecules inside that, those little voids are going to expand, and it looks like you're pulling the oil apart. If you're not trained for this, it looks like you've got a leaky oil system somewhere and you're pulling air in through the supply line to the burner. But in fact, you're actually pulling the air that's trapped inside the oil apart, and that's because there's too much vacuum. Plugged oil line, plugged filter, things like that can cause that. So we'll get into that. I'll show you that in a video when we do live demonstration. I mentioned this pump before. This is the Suntech A2VA 3006. I'm sorry. And what they've done is they've eliminated the fuel cutoff inside the fuel pump and went with an electrical solenoid that's powered by the primary control. And by doing that, they can do pre-purge, post-purge. They can actually run the unit without spraying any fuel. So there's a lot of advantages to that. And it's pretty much a single stage, this particular pump, single stage pump, just like the previous pump, but with this feature on it. Let me go to the specs on this. Here is the online service manual, or instruction manual I should say, for model A 3000 and B, so the single stage and the two-stage fuel units that you can get from Suntech online. Here in the instructions they give you the formula to figure out the length of lines. They do say that the L, which is the length, and H, which is the head, and Q, which is the firing rate. They give you the formulas there to figure it out, to size the oil lines in the fuel pump properly. They under notes, you will notice there it does say that the elbows, valves, and fittings, filters will reduce line length because it adds restriction. And notice the very last note is kind of interesting. It is recommended to avoid 3/8 lines where feasible. So that's interesting. I understand that. Obviously, you can get more oil supply and under less vacuum with a larger line. But they've been 3/8 for many years. If you read here, the inlet line joints must be, let me pull the camera down a little bit so you can see. It says here in the instructions that the inlet line joints must be perfectly tight to maintain prime, so that's obvious. Maximum recommended lift is 8 feet from tank bottom to pump. Good information to remember. Maximum lift, this is for a single stage, right now they're talking single stage, one pipe, no return line. Maximum lift is 8 feet from tank bottom to pump. Prime by opening the bleeder. Bleed the unit until you get the air bubbles out, basically. All fuel units come through with a bypass plug not installed. Yeah, that's for a single pipe system. Single pipe system, you have to purge it. If air gets into the pump, it will just stop pumping. You have to manually bleed it like brakes on a truck. Two pipe system, one of the advantages is that it will self-prime. As long as it will prime and fire during the time limit of the safety before it locks out. That's why on a lot of new controls you'll see it retry, because they'll give it a second try for ignition. So by that time, hopefully, if it's a long run or troublesome, you might get the oil to the burner and it fire and not lock out, so you won't lose your heat. Two pipe system, you need a bypass plug installed inside the fuel pump. These here are the instructions telling you how to do that. That you must put it in the return port on the bottom of the fuel pump, which I'll show you later. There is a plug that you must take out, and there's a small Allen screw plug, in this case a 1/16 bypass plug, it says that right here, with a 5/32 Allen wrench head, and you stick that inside, tighten it down, and that blocks off the bypass port internally inside the pump. And I'll go over detail with that a little later. Okay, here someone took the time to draw us a nice drawing, and this is in the instructions. If you look up there, it's two pipe hookup inside or outside fuel tank, fuel unit above tank. Okay, so in other words, a standard in-ground installation, fuel unit installation. So here you see the tank. Here's your oil tank here, your fill pipe, your vent pipe, your two lines. And if you notice here too on the schematic, you can just see it. Let me just get down just a little bit and maybe zoom in a little bit. If you see right here, you see that 3 to 4 inches? Right there, 3 to 4 inches. And what that is they want 3 to 4 inches, the supply line, if you follow it down from the burner, which is the outside one, is 3 to 4 inches longer than the return line. Say, oh, here's the arrows right here. So supply is longer, 3 to 4 inches. That's to help prevent air bubbles getting caught and getting in and losing your prime in your burner. That's what that's for. It tells you that in the instructions. Okay, let's look at this chart first. This is the 3/8 copper tubing. Whoops, I'm sorry. 3/8 copper tubing over here. This is an inlet tubing size, so 3/8 copper coming in. This is your lift and height, so your vertical lift, you pick however many feet that might be. Then if you look up here, this is a single pump, Model A, single stage. Over here's two stage, Model B. Here's your two different RPMs, the 1725 and 3450 pumps. All right. Then you have the gear set, which is either 3 gallons per hour or the 7 gallon per hour pump. So you have to find what column that we fall in. In a typical residential, you go down, you order a boiler, 3-section boiler, your standard boiler that you buy at your supply house put in is going to have a single stage, 3 gallon per hour pump. So, and it's going to be a 3450 nowadays. You won't find pretty much 1725 are just old burners. You won't find them anymore unless it's old burners. To my knowledge, nobody makes them any longer. So we're at a single stage pump. We're in our basement downstairs. We're at 3450 RPM, and we're also a 3 gallon gear set. So with this chart, and we're running a 3/8 oil lines. So we're going to be using this chart right here. See how that works? All right, and then our total lift. Now, this is interesting. If you add up, we'll say we're going to lift 10 feet. Okay? Now, rule of thumb is that every foot vertical lift is equal to 1 inch vacuum. So this is kind of a rule of thumb that you can use in your head as a technician going in to just kind of figure the vacuum really, really quick. All right? So with that rule in mind, if we're rising, vertical lift is 10 feet. So that's 10 inches of vacuum right there just to do that. Then we go over to our section where our pump is, 3450 3 gallon, and we go down to 10, that column intersects there. It says our maximum line there and back is 31 feet. 31 feet there and back, so that's only 15 feet to the tank and back again. All right, if you're lifting 10 feet in the air. All right, now you can put that into perspective in some of the installations that you've run into. Now I kind of zoomed out and know it's hard to see, but over here it's kind of the same chart that we just looked at, but for 1/2 inch copper tubing. So here's your feet, just like the other ones. But if you notice over here, most of these are hundreds. Almost all of them, until you get way down here and until you're pulling a really, really high lift, because 12 inches of vacuum, you're getting really, really high in vacuum. Because basically you want, on a single pipe system, you only want to pull about 6 inches of vacuum on a single pipe, single stage pump. 6 inches is about maximum. 2-pipe system with the same pump, they recommend about a maximum of 12 inches of vacuum. But if you increase to a 1/2 inch, look at the line lengths, the difference. For instance, say we're coming out, do the same scenario. We got 10 feet of vertical lift. We go over to our pump that we were using. Maximum is 31 feet. Remember? So now the same scenario, 10 feet here, same pump. We're at 100 feet now. So what a difference just by increasing that from 3/8 to 1/2 inch oil line makes a huge difference. To elaborate a little bit on what I just said about the rule of thumb on vacuums and the maximum amount of vacuum, here it says in the operating instructions under vacuum check, a vacuum gauge may be installed in either the 1/4 inch MPT inlet port, all right, which is another inlet on the bottom of the pump. You can put a vacuum gauge. Model A units, which is a single stage units, what we have been talking about. Model A units should be used where the running vacuum does not exceed 6 inches, single pipe, or 12 inches, 2-pipe. Model B units, 2-stage units, should be used where the running vacuum does not exceed 17 inches. All right, there's our guideline. That is so important. So when we go to that service call where a customer complains the oil burner will not continue to run and everything tests out fine, the ignition transformer looks great. The primary control looks great. Maybe you've already changed them because you wasn't sure. All you got to do is throw a vacuum test on that. See what you're pulling for a vacuum. If it's a single stage pump, and know what your pump is, of course. If it's a single stage pump and you're pulling more or greater than 6 inches of vacuum, again, account for age for the pump as well. Older pump won't be as good, it'll be worn out some. But if you're pulling 6 inches or greater, that could be a problem right there. I'm not saying it is your problem, but it very well could be. Now I have seen pumps, single stage, that one single pipe that would pull 12 inches of vacuum, and they did it for years. They're very reliable pumps. It depends upon the integrity of the pump, how it's been treated over the course of the year, and how well it's been maintained. If it's never run dry and overheated, then that pump, and you've never had contaminants in the oil to eat away at it, then that pump will last a long time. Assuming the water hasn't gotten to it, there's so many variables. Water will destroy a pump, air will destroy a pump, running it dry, trying to prime it for long periods of time will destroy it because it gets its lubrication from the fuel oil itself, and that's what keeps it cool. The pressure check, it says here that use only 1/8 inch national pipe thread nozzle port. Okay, so it's only telling you only use the nozzle port to do a pressure test. Do not use the easy flow bleeder valve port. Some guys want to use the bleeder valve, which I was taught that many years ago, but this is the instructions for the manufacturer. You cannot argue with that. It says in capital letters, do not use the easy flow bleeder valve port, as the readings will be too high for nearly all models of this series, resulting in a wrong operating pressure. That doesn't tell you it will not move the needle. It will, but it will tell you it will not be accurate. So you have to go off the nozzle port. Also down here, to check the fuel cutoff, it says units having cutoff, which are the units that do not have the electronic solenoid on top. Units having cutoff can be checked by installing a pressure gauge directly into the nozzle port. Plug off the nozzle port. Run the unit briefly, shut it off, and watch for the pressure to drop, and then hold above 0. All right. Now there's some gauges which I'm going to show you in just a few minutes that I have that you can put on that has a valve that you can turn on and off to check the fuel cutoff pressure. So I just want to run that past you real quick. One last thing I want to show you. is the pump ID system. Here we have, this particular is a B, so a B would be a two-stage pump cycle. A, single stage. If the first stage is A, single stage. B, two-stage. It's pretty basic. Two, it was a 3450 RPM or 1725. That's what this digit is. The third, the letter V, is 3 gallon. This is the gear set. Notice you can get pumps all the way from 3 gallon, which would be your standard residential, all the way up through 34 gallons per hour. And possibly you go into other, which I know you can. You go up into other types of pumps and you can get ridiculously high. But in this series, it will go up to 34 gallons per hour. And then, of course, your rotation, which way it's spinning. If the pump's on the right side or left side, or which side you want your nozzle port on, that's what the last letter signifies. And then the series number, make sure you can see that. Yeah, the series number is right here. The 4006 is just a series number. And then the solenoid specifications is that last number on the very, very end, which is up here, that very last number. So I just wanted to show you that. I think I bored you enough. Thank you for really sticking with me. Now, if you want, we're going to go downstairs. We're going to hook up some gauges, and we're going to test this and see what cavitation looks like, what pressures and vacuums looks like, and see what's going on downstairs. Hope you stick around.